Let us learn how to read and design relational schema diagram in this video. As we discussed earlier, a database is composed of multiple relations. Each relation represents a table described by multiple attributes. Each attribute has their own domain. So the data type associated with the domain typically including the basic data types that we understand in our programming languages. They include numerical data type for integers, real numbers, decimal numbers, floating numbers, precise numbers. Those are the numbers or data types that we understand. It can also be characters. It can be Boolean, it can be fixed length strings, time, date, money, etc. While we try to define each data type, we also need to associate how many spaces of that data type we need to reserve. For example, if we are looking at the integer, we need to specify not only the integer, but 3 digits of integer or 5 digits of integer. You see that when we define that number, 5 digits, 3 digits, we define the domain of that attribute. It's the same thing about the money, Boolean, fixed length strings, etc. A relation is defined as a set of tuples, and therefore, in order to distinguish one tuple from the other, we need to have a key constraint definition to understand how do we distinguish one from another. And of course, in database, by definition, all elements of a set are distinct. They cannot be duplications of the two tuples, and therefore they have to be something different. This means that no two tuples can have the same combination of values for all of the attributes. And therefore, before we look into the key concept, let's talk about the idea of the superkey. So a superkey is a set of attributes. So you can think about, we will pick up several attributes that no two distinct tuples in any state R of R have the same value, so that this set of attributes that we picked can be used to distinguish one from another. Every relation at least have one default superkey, which is the combination of all of the attributes. Since the definition saying that they cannot be all the same, then if we pick up every single attribute, that is a default superkey. Using the slides that we have seen earlier as an example, you can understand saying that I have a relation has only 2 attributes, and the attribute has very specific domain. The A1 is a Boolean attribute, A2 has only 3 possible choices over there. By definition of the database, this database can have at most 6 tuples, because that's only the 6 combinations it can have. And of course, the default superkey might be the only superkey that you can find in this example is that you need to pick up A1 and A2. The combination of A1 and A2 is a default superkey for this table. And of course, usually we don't have this limited amount of possibilities, or the domain is much wider than this case. So a superkey can have redundant attributes. So more useful is the concept of the key that removes the redundancy. The key attributes specify the following constraints. 2 distinct tuples in any state of the relation cannot have identical values for the attribute in the key. The first one is still the idea of the superkey, but the second criteria changes from superkey to key. So the key definition has the second criteria that lies in it is a minimum superkey. Let's take a look of a little bit examples to understand it. Say now we have a student relation. The attribute set social security number, obviously, you can understand a social security number is obviously a key to student relation. It is also a superkey because we pick up only one attribute that forms a superkey to the student relation. anything else, any combination that includes the social security number can be considered as a super key. For example, social security number plus name. In that case, social security number and name would form a super key to the student relation. But it is not minimum, because if we remove the name, we still get social security number as the super key, and more importantly, the key concept. So that this is the ideas of what is a super key. Obviously, if a super key, the choice of the super key includes the key attribute, then it is a super key. Think about this. If we try to pick up name and age, can that be super key? The answer is probably no, because it's totally possible to have two persons that have the same name and happen to be born on the same year. So in that case, name and age cannot distinguish from one person to the other. So that cannot be a super key. In general, besides the idea of the key and super key, a third key terminology I want to introduce to you, and you have heard about this before, is the candidate key. In general, a relational schema may have more than one key. In this case, each of the key is called a candidate key. Let's take a look at the car examples that we see earlier. The car can have two keys. The first one is a composite primary key, which combination of state and registration number. So that can be a key. On the other one, a serial number or the VIN number itself can be a key as well. So what to choose? It's depending on the application, but you understand that both of them are our candidate keys. So both are super keys of the car. Serial make is a super key, but not a key because serial number itself is good enough to be a key, so it's not minimum. And therefore, this is ideas of super key, key, and candidate key. So this is the example. Try to understand it. We can use the serial number as the key, while we have the license and the number are the combinations of the two forms another key possible. So this is a candidate key. This is also another candidate key. Key constraints. So since we know key is such an important thing, so there's a lot of rules apply on the key. If a relation has several candidate keys, one of them need to be chosen as the key, or what we call the primary key. For example, we can choose the car by underline the serial number or the VIN number. That's indicating in this design, we choose serial number as the primary key. The primary key value is used to be uniquely identify each tuple in a relation. That is the number one useful thing about the key. However, it's not just that. The second important idea of the key is that it also used to reference the tuple from another tuple. You know that in a database we may have multiple relations. Each one of them will link to each other. So the ideas of the primary key is not only used to identify your own tuples in a same relation. It is also used to be referenced by another table. So that's why key definition is such an important thing, not only involving on the table yourself, but also other tables. Another constraint on attributes specify whether null values are permitted or not can be applied. If you are defining a primary key, you cannot be nulls for the attributes already. At the same time, you can still say that, for example, student name cannot be null. Those are the things that we see when we try to apply a credit card on the internet. The boxes we need to input, the box with the star sign indicating a not null constraint. And therefore, you understand that not only the primary key must have a not null constraint, it is totally possible to apply some other attributes which are not primary keys to have a non-null constraint. So to design or to understand a relational schema diagram, we are very close to it already. So a relational schema diagram consists of the following things. A set of S of relations, so we will have multiple relations indicating we will have multiple tables. S is the name of the whole database schema, which S equals to our relation 1, relation 2 until relation n, which indicating that S in our company example is that S is a company database. So a company database is composed of 4 different tables, including employee, department, projects, as well as dependents, for example. So that you won't really see the company inside of the relational schema diagram, but what it's trying to say is that these relations combined together forms a company database. So R1 through Rn are indicating the relational schemas. Following slide shows a company database schema with 6 relation schemas. So you can see that for a company database, you don't really see the company inside of your relational schema diagram, because when you sums up all of these 6 things together, you formed a company database. So what is this company database looks like? It has the 4 tables that we discussed in the ER diagram: employee, department, projects, and dependents. And if we look a little bit closer on the employee, you will see it has first name, middle name, last name, social security number with the underline indicating we choose social security number as our primary key. Birthday, address, sex, salary, supervisor, social security number, and department numbers. Obviously, this relational schema is not completed yet because it shows that there are 6 tables. But how do they interact with each other is unknown yet. You can see that for the department number, this is clearly saying that which department that they work for. So there must be a linkage from this department number to the department number over here. For department, it has department name, department number, who is the manager. So obviously this manager social security number will have some linkage with the employee's primary key, which is social security number. So try to understand what's describing here. For a department location, it has 2 attributes. Both of them are underlined. Why is that? This is something interesting. Because it is both, because they are all underlined, indicating that a department has multiple locations. So you think about this. If we have one department, department number 1, located in Conway, while the same department wants to locate it in Little Rock, it will have to underline both of them to form a composite primary key so that we can uniquely identify one from the other. If you only underline department number, then you can see department number 1 located in Conway. If we have another department 1 located in Little Rock, both of them are 1 and 1, and that if we only underline department number, we are not able to distinguish one from the other. The same thing, if we only underline department location, one department located in Conway, the other department cannot locate in Conway anymore. So that is obviously not a design, and therefore we need to underline both of the attributes to specify what it looks like. For project, it has project name, project number, underline, project location, department number indicating which department that they belong to. Works on indicating that who works on what project. If you still recall, this is where we look into our M to N relationship. Finally, for the dependent, not only you need to specify the employee social security number, but also dependent name to form a weak entity type. There's a lot of connections from ER diagram to relational schema diagram. Right now, you don't really need to have a full understanding about this one because in the next chapter, we have a step-by-step conversion. But at this stage right now, you need to understand what are the relations looks like, what are their attributes, how do we define primary keys for each one of them. Now, let's take a look of the formal definitions about the integrity constraints. So basically for entity integrity, the primary key, when you define as a primary key, which you put an underline of the attribute, that each relation R in S cannot have null value. So this is a formal definition indicating that a primary key cannot be null, basically, because it needs to be uniquely identified from one to the other, and other attributes also need to reference it. So other attributes of R may be constrained to disallow null values even though they are not member of the primary key, just like the name as well. After we look into the primary key, which we spend a lot of time, it is time for us to look into what we call the foreign key. How do you reference one attribute to the other one? So referential integrity constraint is specified between two relations and is used to maintain the consistency among tuples in two different relations. Informally, this is how we can define. A tuple in one relation must refer to another existing tuple in that relation. This is a very loose definition, but you need to understand that that's how we're referencing another one. For example, employee works for department number 5. That department number 5 need to be well defined in the department table already. Otherwise, you are referencing something does not exist, and that cannot be right. So this is what we have the example over here. Therefore, if we take a look of the closer look on the data itself, this is probably your first time to look into a real data. Employee, you can see that we have like 8 different employees. Each one of them is working on certain department. Pay attention to this one. You will see that we have 3 different department numbers because we have 3 departments defined here. We have not defined department number 2 or department number 3, so they cannot referencing department number 2 or department number 3. It's the same thing about the supervisor social security number, indicating who is their supervisor. For these numbers, they have to be existed in the social security numbers over here. This is where you see the recursive relationship. It's going to be the same thing, department locations, indicating which department located in what location. And this is what we can see when we see the real data. Again, this department locations has to have both attributes underlined, indicating it's going to be a composite primary key. Again, if I only underline the department number, you can see that there are 3 tuples referencing department number 5 already, so that cannot be right. If I only underline department location, Houston and Houston are appeared twice over here, and that cannot be allowed either. And that's why underlying both to specify this multi-value concept is necessary. Tuples in referencing relation R1 have attribute of the foreign key that reference the primary key of the reference relation R2. That is not very easy to understand, and therefore, I think this is the best way to understand the definition of the foreign key. What this is trying to say is that for a relation R1, the foreign key is referencing another relation, table 2's primary key. So a foreign key must reference another table's primary key. This is the most important thing you need to remember for the foreign key. Table 1's foreign key equals another table's primary key. That forms the foreign key. That is the referential integrity. So each relation schema displays as the role of the attribute of the names. The name of the relation is written above the attribute name. The primary key is underlined. So we already see these 3 things in our relational schema diagram. Now, foreign key is the next important thing. Once we go through this one, we can create the complete relational schema diagram. A foreign key constraint is displayed as a direct arrow from the foreign key attributes to the reference table. Not only the reference table, it needs to go to reference table's primary key. So that is the most important concept over here. So let's take a look at this one. You see that the employee indicating which department it works for, you form one line goes to the primary keys of the department. So you see that employee's D number is the foreign key referencing another table's primary key. Therefore, whenever you see an arrow, that has to be under the primary key, because that's what's referencing another table's primary key concept. It is totally possible that using department locations as an example, department location as a composite primary key. One of that indicating the department has a foreign key referencing the primary key of the department. That is totally doable. That's totally allowed. Another example is the works on. Think about this. Works on indicating that employee can work on multiple projects, while multiple projects can work by multiple employees. In this case, this is an end-to-end relationship. That's why we need to create an additional table, which is what we call a works on, that the primary key of works on is a combination of ESSN and PNO. At the same time, both of them are foreign keys referencing other two tables. So this is the relational schema diagram that helps us to understand not only the relations existing in the company, but also how do they link with each other. And therefore, this is the complete relational schema diagram of what we're looking at the company database. The last constraints I want to talk about is the semantic integrity constraint. Based on application semantics and cannot be expressed by the model per se, including what's the maximum number of hours that a person can work. These kind of things will not be able to appear on the relational schema diagram. However, when we are trying to write the code to create a database, we will be able to specify that. Again, if we come back to one slide, once we have this relational schema diagram, we are very close to translate each information in this relational schema diagram into the code, what we call the Oracle data definition language, to really create the space of holding the database. Finally, I'm going to give you an assignment to make sure you have studied it. So consider the following relations for a database that keep track of university on faculty perspective. So a faculty is defined by first name, last name, faculty ID, rank, home department. Department has name, ID, and building locations. Courses indicating the course name, course ID, offering department, and the major responsible faculty. So I want you to do this. This obviously defines three relations. Try to draw the relational schema diagram based on three relations. Provide all the attributes listed over here is pretty simple. Underline the primary key and draw the foreign keys on this assignment. Based on the information, you need to think about which attribute is referencing what attribute. And again, a foreign key concept indicating a table's foreign key reference another table's primary key. That is the key thing to think about when you draw the foreign key. So I want you to draw the complete relational schema diagram of this database and submit this through the Blackboard.